Okay, next thing I want to look at is correlations, which on the one hand seem very, very simple. A lot of us are familiar with correlations, and on the other hand, are very often misinterpreted. Uh, First of all, we need to recognize that correlations have certain attributes. The main purpose of them is they are to show relationships between two sets of data, or how those two sets of data are related to each other. Just because these two pieces of information are related, though, that does not mean that one has any cause or effect relationship on the other. So just as an example, if I were to collect two sets of data in terms of the number of years of experience that somebody has and how much money they make in terms of thousands of dollars per year, I could put it in a format that looks like this. So for example, this is subject number one. They have 0 years of experience and they make $20,000 a year. Subject number two has 5 years of experience and makes $30,000 per year, and so on and so forth all the way through. Now, the question we ask is, what kind of information is included? Well, obviously we know how many people participated in this study, the number of years of experience each of those individuals have, and their income in thousands of dollars. We know that this is a range of years of experience, and this is a range of thousands of dollars. We could take things like the average years of experience and the average income in thousands. So going back to our table about how to choose a statistical test, because both of these types of data are interval types data or ratio data, then what we'd want to do is something called the Pearson's correlation. So as we said, what we're talking about, this is measurement data. It is the interval or ratio type data. And although this is a small sample, for all practical purposes, we could say that we need to do a Pearson correlation because I'm trying to quantify the association between two variables. So this data gets put in, and we punch a couple of buttons in a software program called SPSS, and we get something that looks like this. Now, hopefully you'll remember seeing something like this from high school algebra, that this is a scattergram. And what it shows is where each of these data points are and the relationship between the years of experience that a person has and their income in terms of tens of thousands of dollars. And what we see is that as a person gets more experience, their level of income goes up. And that these dots are on either side of a line that we call the line of best fit. So this shows a positive correlation between the two sets of data. Now, just because we see this picture, that doesn't necessarily mean that's all that we want to know. We need to collect something else. So this is the first point that we're going to see something called a level of significance. We want to know what the R value is. The R value is the actual statistical representation of this line. Correlation coefficients can range anywhere from -1 to 0 and 0 to +1. If something is a +1, that would be a perfect correlation. That means as one thing went up, the other one would go up. And if it was a perfect correlation, all these dots would be sitting right on top of the line, and the line would be a perfect diagonal. That never happens. A negative correlation would be a -1. A perfect negative correlation would be a -1. And this line would be going from top to bottom, and all the dots would be sitting on it. If there was no correlation, this R value would be 0. The other number we need to look for when we're looking for whether or not something is a value is something called a p-value. It's called a level of significance. And this is, for lack of a better term, the odds that what we're finding is true. This is based on something called hypothesis testing, which we'll get into later. But basically what we want to know is is there any chance that we are saying something that's true that's not? And sometimes that can happen. And we're willing to say that's okay if that happens sometimes. But we only want that to happen in 5 times out of 100. So at least in education, in this course, all of our level of significance needs to be less than 0.05. Anything greater than 0.05, including 0.05, means that it is not significant, and we cannot accept that what has happened is true. This, for example, is 1 chance out of 1,000. That's a pretty small chance that we've made a mistake. So in this example, this is a strong positive correlation with a significance level of 0.001. Now, the other important value to remember is this number. This is called an R-squared. Sometimes this number is given, sometimes it's not. This number comes from this one. If you were to square 0.858 and multiply it by itself, that is, we would get this thing called explained variance. This is called the R-squared. And what that means is there is a relationship between years of experience and how much money somebody makes in this data set. But because there is not a perfect relationship, something else is contributing to how much money people make. It might be gender, it might be certification as extra degrees, things like that. And it's something that we don't know, we didn't account for. The years of experience and income, we could say, are related, can be explained because of those two data sets by this much. Another way of saying is 74% of that relationship is defined by the two variables. But there's part of it that we don't know. It's the unexplained variance. So in this case, what you do is you subtract this from 1, and the unexplained variance would be 0.26. That's how much we don't know about what is happening in this relationship, which is an important thing to keep in mind. Now, there's lots of ways to look at this information. There are strong negative correlations. There are no correlations. There are strong positive correlations, weak negative correlations, weak positive correlations. And they end up looking something like this. So for example, here's a data set where there is no correlation at all. Here's a relationship where there is a positive correlation. Here's a relationship where there's a negative correlation. But this one and this one are perfect relationships. In this example, here is a positive correlation of 0.6. So yeah, it's related, but it's got some variance in it. The dots are not laying right on top of the line like they are up here. And again, here's a weaker negative correlation. The line's going top to bottom and down. Now, people ask, well, how strong is strong? Well, here's the guide by which you can judge this. The size of correlation can be 0.8 to 1.0, and we call that a very strong relationship. A 0.6 to a 0.8 is a strong relationship, etc. is moderate, weak, and weak or no relationship. But keep in mind, this can be a negative. You can have a negative 1.0 of a relationship. That's still a very strong relationship. It's just a very strong negative relationship. And just because it has a strong relationship, if this value were a 0.8 with a p-value of 0.36, yes, that's a strong relationship, but it's not significant. That means that we don't know for sure that what we're seeing is true. It takes both numbers, and we'll see some examples in some of the papers that we'll look at. One of the things that we're going to put on the discussion thread is this. This is my favorite correlation. This is the correlation between average global temperature and the number of pirates in the world. And what we see is as we have less and less pirates in the world, we have an increase in global temperature. So one of the discussion threads we're going to look at is what is happening in this relationship, and it also shows you with the little pirate heads when this is happening. So there's a discussion thread that you need to take a look at. And there will be a discussion thread about this. There's a positive correlation between ice cream consumption and drownings, ice cream consumption and murder, ice cream consumption and boating accidents, and ice cream consumption and sharks. And what I want you to do in the discussion thread is explain to me why these are happening.